So welcome children once again, and today we are in continuation with the previous video, that is user defined function. And user defined function means children the functions which the user first defines and then he uses. So how to define a function, this we already have discussed in the previous video, and I told you that whenever we use function there is a two-step process. First we have to define or create a function, and then the next step is to access a function. So today in this video children we are going to study about accessing of a function, and then accessing of a function we say that using of a function. So accessing of a function can also be called as referencing a function, executing a function, using a function, calling a function, passing a function. So these are different terms which can be used for using these functions. So it is that a function is created, now we are using those functions, so it is called as accessing a function. So children, when we access a function, we say that to access a function we have to provide a function name followed by the list of parameters enclosed in parentheses. So whatever function you want to use, you have to use it by providing a name to it. You can use a function defined in the same class, and you can even use functions which are defined in other classes or even in other packages. You can use those functions. So here I'm showing you this accessing a function by a simple example. Here I have written my class, or I have written my program class ABC. In this I have defined one function called public void display. So this is the function I am defining, I am creating, and in this function it is a non-returnable function since its return type is void. So in this function I have just written system.out.println hello merit. So that is what I have written in this function. I have created another function, the second function over here, that is public int sum. So the function name over here is display and the function name over here is sum. And in this function it is a returnable function since its return type is int, and it is having two parameters. So when you define a function, it can be without parameter list and it can be with parameter list. So this function is having two parameters which are of type integer. They are int x and int y. And children, in this function the definition is written like this, that you are adding x and y and the sum you are storing in z, and this function is returning the sum of x and y. Whatever value will come in x and y, the sum of that will get calculated and it will return. I have created another third function called calc. In this my parameter list is of type double. Here it is of type integer, but here it is of type double. And in this function I have multiplied these two terms to these two numbers L and B, and whatever product is there, that this function is going to return. So these are the three functions which I have created. That is the first part of it. Then I come to my main program and I have taken some values over here. These values can be inputted by the user also. And here I have taken two integer values A and B, A as 10, B as 15. And I have taken double D as 10.5 and double E as 7.2. Now children, I am calling these functions, or I am accessing these functions, I am referencing these functions, and to call this function display I have just written display because it is a non-returnable function. So when I write this display, the control is going to get transferred to this function, and whatever is this function doing will get executed. So this function is printing hello merit, that will get displayed on the viewer screen, and the control is going to come back to the next line. So this is how I am calling a function. This is calling of a non-returnable function. But children, when I call a returnable function, so both these functions are returnable functions and they are returning a value. So I have to either assign them to a variable. I cannot call them like this, like a non-returnable function, because these functions when I am going to call, they are going to give me some value. So that value I am storing it in these variables v1, v2, v3 and v4, and whatever value they are going to return, that data type also we have to declare over here. So when I call this function, these returnable functions either must be assigned to a variable, or you can use them directly in an expression, or you can even use them with the print statement. With the print statement, whatever value is going to come, that gets printed. You cannot use them like this as a non-returnable function. So here children, I am using, or I am calling a function sum. So I am calling this function sum, but here I have taken this function thrice. And in the first case, I am calling it by the values a and b. A and b are these values. A is storing a value 10 and b is storing a value 15. So children, when I call a function, these parameter list must have some values. And when I define a function, these parameter lists do not have values. They are only used to define a function. So children, there is a difference. The parameters or the arguments which we write at the time of defining a function, they are called as formal parameters. So we must know the names of them. They are called as formal parameters or arguments. They are also called as dummy parameters, formal or dummy parameters. But the parameters which I use at the time of calling a function, then these parameters must have some values in them, because these values are going to get passed to the formal parameters. So children, here the value of a is going to get stored in x and the value of b is going to get stored in y, and in this function, since it can only access x and y, so it is going to use x and y in place of a and b, and it is going to return that value. If I call the same function again sum, but here I am calling it with values 5 and 7. This is a variable, this is a constant. So this value 5 gets stored in x, this value 7 gets stored in y, and x and y now have values 5 and 7. You get a different answer. This function returns a different value. In the third case, I am using an expression. So my parameter is a plus 5. A is 10. So 10 plus 5, that makes 15. 15 value will get first calculated and then it will get stored in x. Over here it is b minus 2. So 15 minus 2, that becomes 13. This value is first getting calculated and then it gets stored in y. And then this function is going to calculate the sum of these two numbers. So children, you can say that using a function, we are using the same function, but we are calculating the sum with different numbers. And these parameters which I am using over here, these are called as the actual parameters. So these are called as the actual parameters, and this is the formal parameters which we are talking about. In the same way, children, I am calling my function called calc. The third function which I am calling is calc, but since it is of type double, so I have taken this variable as double and I have taken the variable as v4, and now I am using the actual parameter as d and e. That is double d, which is 10.5, and double e, which is 7.2. These values will get transferred, will get copied to L and B, and the product of these two numbers get calculated and this function returns its value. So this d and e, or a plus 5, b minus 2, 7, 5 and 7, a and b, these are the actual parameters because they are used at the time of calling a function, and these are the parameters which are used x and y, L and b in defining a function, so they are called as formal parameters. And children, we are calling or we are accessing a function by stating the name of the function followed by the list of parameters being sent enclosed in parentheses. So I hope accessing of a function is clear. Now since you have two types of function, a non-returnable function and a returnable function. So the functions which are non-returnable, you directly call them by just stating their name, and the function, whatever the function is doing, that thing get executed. But if a function is returning a value, then you have to assign it to a variable, or you have to use it in an expression, or you have to use it with a print statement. So I hope children this accessing of a function is clear. Now the next thing which comes over here is the formal parameters and the actual parameters. So many times in the board exam, the questions on formal parameters and actual parameters are being asked. So children, the next thing which I am teaching you now is formal parameters. So formal parameters, we say, are the parameters which are used at the time of defining a function. Formal parameters are the parameters which are used at the time of defining a function, and these parameters are always variables. They are always variables along with their data types. Along with their data type. And children, actual parameters are the parameters which are used at the time of calling a function. So at the time of calling a function, the parameters which we use, they are called as actual parameters, and these parameters may be variables as shown over here, a and b. They may be constant also, as 5 and 7 are constant values, or they may be expressions also. So it is a difference over here, that here it is always variables along with their data type. Here it can be variable, constants, or expression. So the actual parameters are the parameters which are used at the time of calling a function, and these actual parameters may be variables, constants, and expressions, whereas formal parameters are the parameters which are used to define a function, and they are always variables along with their data types. Since at the time of defining a function these parameters do not contain any value, they are also called as dummy parameters. So I hope children this is clear. Now there is one more thing. This is the difference. One similarity is there, that the number and the data type of the actual parameters and the formal parameters must correspond to each other. That means that if a formal parameters are two parameters and both are of type integer, then when we call this function, then the actual parameters must correspond in number as well as in data type with the formal parameter. So the actual parameters and the formal parameter must be same in their data type and in their number. Suppose this is it, then we must have two integers. This is also called as the signature. So the signature of the function definition must match with the signature of the function calling. So these things are to be clear. I cannot use another variable over here and call, then the signature will become different. So children, I hope the formal parameters and the actual parameters are clear to you. Now children, one more topic we must know, that what are the arguments to functions, or we can use the heading arguments to functions. So arguments to function means that the arguments of the function, which can be formal parameter or actual parameter, is of two data types. Is of two types. First is primitive data type. So all these data which I have written over here, they are of primitive data type, which may be byte, short, int, long, then float, double, char, and you can even have boolean. And children, the next is, it can be of reference data type. That means it can be of composite data type. That means it can be an object or it may be an array. So the arguments of the function may be of primitive data type and they may be of reference data type. I hope children this is clear to you. Now calling of a function, we can call a function in two ways also, and that is called as call by value and call by reference. And I hope children accessing of a function is clear. Now accessing of a function is done in two ways, that is call by value and call by reference. So we are going to continue with call by value and call by reference now. So children, now we are into calling of functions, and calling of function, I am saying that calling of function is done in two ways. That is call by value. It is also called as pass by value and call by reference. So children, here I am showing you one example of call by value. This is all call by value. What I am doing over is, I have written a class ABC. In this I have defined a function. So I have defined a function called public void change. It is a non-returnable function and it is having two parameters or two formal parameters, a and b. So children, here after this I am in my body, I am changing the value of a and b to 0, and I am printing over here system.out.println x is equal to a, as my a is representing to x later in the program, and y is equal to b. I hope this definition is clear. Now I come to my main program. I am going to execute this program. In this program children, I have declared two variables and initialized them as int x is equal to 10, y is equal to 20. Now children, in this particular program I printed out the value of x and y, that is I printed out x is equal to 10, y is equal to 20. So the output of my program initially will be x is equal to 10 and y is equal to 20 because of these two statements. Now children, here I am calling my function change, and this calling I am calling it as call by value. So in call by value I say that call by value, or in call by value, the value of the actual parameters over here are x and y. The value of the actual parameters are x and y, gets copied onto the formal parameters. So here what will happen? These actual parameters, the value of these actual parameters will get copied onto the formal parameters like this. Now children, I have shown two memory location. This is the memory location of my main function. Since it is a method variable, so it is available to me in the main method, and in my change function I have used two variables a and b, which I am showing over here. So when I call this function by call by value method, then this actual parameters, the value of these actual parameters get copied onto the formal parameter, and the called function, this is the called function, this is the calling function, and the called function uses its own copy of argument. That means this change function is going to use its own copy, that is, it is going to use a and b and not x and y. Since the value of x is copied to a and y is copied to b, so this function in place of x is going to use a, and in place of y is going to use b. Now children, this function is going to use a and b in place of x and y. Now if we change, that is not necessary we change, but if we change the values of these formal parameters, as I have changed over here, a to 0 and b also to 0, and I print out again x is equal to a and b is equal to y is equal to b, since x is representing a and y is representing b. So my value will get printed like x is equal to 0 and y is equal to 0 because I have changed its value. Is it clear children? But after printing this, my control will come back to the main program. And in the main program children, I want to see whether my original values are changed or not. So when I again print the value of x and y, so here in the main function is going to use its own value, that is x and y, and if it prints x and y, that means it prints 10 and 20. So you can see that call by value, which is over here, is a method of calling a function where the values of the actual parameters gets copied onto the formal parameters, and the called function uses its own copy of formal parameter within the function. And if any changes are made in the formal parameters over here, those changes are not reflected back to the actual parameter. That means in call by value method, the called function creates its own copy of arguments and uses them. Even if these two statements would have not been written over here, then also while printing it would have used these variables and it would have printed 10 and 20, but it would not use the parameters defined in the as the actual parameters in the main function. So I hope children this method of calling is clear. This method of calling is useful in those places where we want to use the value, but we don't want its value to be changed. As you can see that this function change has changed the value of the formal parameter, but it has not reflected back to the actual parameter. So in those programs where we want that the actual values must not get changed or do not get changed, then in those cases we use this function call by value. The next is call by reference. Reference means reference data, which is object. So I'm going to explain this also with an example, but detailed study of call by reference or programming on call by reference this time is not going to come. As we are following the reduced syllabus, it has been reduced in that part, so that topic, but we'll study about call by reference method also. So I'll just write an example, we'll come back. Please continue. So children, now we come to the next calling, that is call by reference. And as I told you that all the arguments, if you are having arguments of reference data type, it is done by call by reference. So all calling by reference is reference data type is done by call by reference, and all calling by primitive data type is done by call by value. So children, in call by reference, I'm just going to show you an example over here, that I have written in a class over here, class ABC. Then I have written two variables over here. These are called the instance variables or the object variables. Then this is the constructor I have made. So I have used an instance variable, I have used a constructor. Constructor will be used that when we are going to create object of this class, this is going to provide value to the objects of the class. Now we come to the main method. This is my main area or main memory space. In this I have created an object A. So object is created, object is of class ABC. So ABCA is equal to new ABC. New ABC means I am creating this object with this constructor. So children, in the main memory, this object gets created. Object's name is A, and it has got two instances, A dot X, which is storing a value 10 according to the constructor, which has given the value, and A dot Y. These are two instances of the object. So A dot X is storing a value 10 and A dot Y is storing a value 20. Now children, I have used this object and I have called a function called output. This is my output. In this output, I am just printing out the value of X and Y. So with A, I am using the function output. So it is going to print out my value of the object A. That is, it is going to print out this value A dot X and A dot Y. So when it prints out this value A dot out, because of this, I will get this output X is equal to 10 and Y is equal to 20. Now children, here I am calling a function. I am calling a function by stating its name followed by the argument. Here the argument is object A. Since the argument is reference data type, it becomes call by reference. Now children, here I am calling the function called change. This is my function. So when I am calling a function change with object A, here is the change. So here I have used another object which is B. So according to the previous concept by call by value, so what would happen is that the value of the actual parameter, this is the actual parameter, must get copied onto the formal parameter. So this object would have been created over here and this value must have been copied. But children, in call by reference, this called function which is change, it is not creating any memory space. It is not creating its own variable. Rather, what it is doing is it is using the actual parameter. The called function is using the actual parameter with a different name, that is with the formal parameter, or with the, this is the actual parameter, so it is using. So what this change function is doing is, it is not creating its own copy of argument, it is not making its own copy, it is using the same object with a different name. So here this object B is the formal parameter, it is using the actual parameter, but here it is using it with a different name. So you have the same area, you have the same object, but it is referred by two names. In the main method, it is referred by A, and by the change function, it is calling the same memory location with a different name. Now it is very possible in our daily life also, we call an object by two names. We call it an apple also, we call it save also. So and the same object can be called by two different names. That is what it is doing over here. So now children, when we call this function by call by reference, the called function, which is this function, does not create its own copy of argument, and it uses the same object with a different name. Now if any changes are made in the called function, say I am making this changes, or you can say that this change function is going to use this original value, and if it is going to make any changes in its own argument, that change is going to get reflected in the actual argument. Say if I say that in the change function it is making the value of b dot x and b dot y as 0, so it is going to change this value over here as 0, and it is going to change the value to 0. So that means the actual value is changed. Now after changing the value, if I print out the value of object B by using the function b dot output, so now my output will be x is equal to 0 and y is equal to 0, since it is using this function. Now children, after this my control will again come back to the calling function, And when I go to this line, to the next line where I am again calling my output function with object A, since the value of object A is changed, and if I print out the value, it will be again 0. In the previous case, in call by value, the actual parameters was not changed, but here in call by reference, the actual value has been changed. So this type of calling, where so we can say that call by reference is the method of calling a function where the called function does not create its own copy of argument, rather it uses the actual parameter with a different name, and if it makes any changes in the formal parameters, those changes are reflected back in the actual parameter. This is called by reference. And children, this call by reference method is useful when we want to change the value of the object. And you can say that in call by value, the values do not change. In call by reference, the value may change or it may not change also. So children, here you can see that the value is being changed. If I don't use these statements, say if I don't write the statement, then also it would have been called as call by reference, because this function is using this memory location or this object and not object as B. Although it is calling it a B, but it is not created its own copy. It is using the same object with a different name. So children, I hope this call by reference is clear to you. So all the primitive values are called by value, and all the reference data type are called by references. And one more thing children, here I want to tell you one more thing, that we can even classify our functions as pure functions and as impure functions. So we say that pure functions are those functions which do not change the states of the argument received. Like all the functions called by value are pure function. And if in this case also, if I don't write this, then this function is not changing the state, then also it will be called as pure function. So pure functions are those functions which do not change the state of the argument received, and they are also called as they are also called as accessor functions. So pure functions can also be called as accessor function. And children, the next type of function is impure function. So we are impure functions are those functions which on execution changes the state of the object received. As in this case, if we just remove this and we use these two statements, then this function which I have shown over here is an example of impure function. It is also called as mutator. So impure function is also called as mutator function. These function changes the state of the argument when they get executed, and pure function, they do not change the state of the object when they get executed. Now children, we have done call by value, also call by reference. In call by reference, this time we are not going to get any complete question, but we are going to get questions in call by value, and differences may be asked in all these things. Pure, impure, you must know formal parameters, actual parameters, you must know calling a function, you must know actual and formal parameters. I have told you that difference is asked in these parameters. So here children, almost all the theory I have done, but children, I can even in some of the books you will see that the functions are being classified, or they have been defined into different forms. So functions we have defined them as returnable functions and non-returnable functions. Now we have defined them as pure functions and impure functions. We also have defined them as a single returnable function. That means it is defined in a single line, or multi-line returnable function if it is defined in more than one line. Then it is also called as single non-returnable function. As I wrote the function display, it can be multi-line non-returnable function. So you can you have a recursive function which is not there in the syllabus. But children, all these are different ways, and you can even classify your functions as computative functions, like all the functions which are computing some values. Then manipulative function, all the functions which are manipulating some values and they are returning you the value in true and false, like functions where you are checking the conditions, or which have a boolean returnable value. And you can even have procedural functions which do not returns any value, but they are performing some task, like println. So these functions can be even classified according to the mode of operation or according to how they are written. So please don't get confused in all these functions. They are all these functions, we are calling them by different names. So I hope children this functions, user defined functions, calling, all these things are clear. Now in my next video we are going to do some programs which are asked in section B. One complete question is always asked in section B on functions. So we are going to do few here questions from the board paper in the next video. Then thank you very much children.